Welcome to an exploration of the SAMR model, a practical roadmap for meaningfully integrating technology into classrooms. In this presentation, we'll unpack how simple digital replacements can evolve into transformative learning experiences and outline why moving beyond convenience toward intentional instructional design matters for student engagement and outcomes. Let's start by understanding what SAMR actually is. A four-stage framework that helps educators move from basic substitution to full redefinition of learning tasks. It's not a rigid rulebook, but a guide to select technology that advances your instructional goals, unlocking deeper student-centered practices along the way. At its core, SAMR was developed to make technology use purposeful, rather than accidental. The model traces a progression: substitution, augmentation, modification, and redefinition, each stage showing how tools can shift a lesson from mere digital replacement to genuinely new learning possibilities rooted in pedagogy. Why does SAMR matter now more than ever? The pandemic forced rapid digital adoption, but that alone doesn't guarantee better learning. SAMR gives teachers a roadmap to turn emergency tech use into thoughtful, student-centered experiences that promote personalization, sustained engagement, and measurable learning gains. It helps to picture SAMR as a spectrum rather than a ladder. The first two stages enhance existing practices while the latter two transform them. Each stage offers real value depending on your goals, and the model encourages thoughtful blending rather than a one-size-fits-all climb toward higher technology. Substitution is the simplest place to begin. Technology replaces a traditional tool without changing the task. Think digital worksheets instead of photocopies, or a word processor in place of handwriting. Substitution is valid and often useful, especially when it increases convenience or accessibility without disrupting core learning aims. To clarify substitution, imagine students typing essays in a word processor instead of handwriting them. The learning outcome stays the same, but efficiency, storage, and organization improve. While it doesn't transform pedagogy, substitution introduces foundational tech skills and can free up time for deeper learning when used intentionally. In practice, substitution often looks like uploading worksheets as PDFs, running the same quiz in an online platform, or using digital whiteboards in place of chalkboards. These tools mirror traditional tasks while offering practical benefits like eco-friendliness, easy sharing, and saved session notes for later review. A critical point to remember is that substitution alone does not change learning outcomes. The key question is whether the technology adds genuine educational value or simply offers convenience. Sometimes pen and paper remain the better instructional choice, and that's perfectly okay. Augmentation moves beyond mere replacement by adding functional improvements that enhance the learning experience. At this stage, technology still supports the same fundamental task, but it provides tools that make the activity more effective, efficient, or accessible for students and teachers alike. Examples of augmentation include word processors with spell check and grammar tools that support self-editing, or platforms that embed multimedia to clarify concepts. These features encourage greater independence and can shift lessons toward more student-centered practice, while still maintaining clear links to traditional learning objectives. Common augmentation practices include digital research using up-to-date online sources, multimedia presentations that integrate video and audio to deepen understanding, and gamified platforms that provide instant feedback and motivation. Each of these enhances engagement and broadens the ways students can interact with content. Interactive quiz platforms illustrate augmentation well. Students receive real-time feedback that reveals knowledge gaps. Teachers access analytics to tailor instruction, and gamification elements increase motivation through leaderboards and badges. These tools help teachers respond quickly and students stay invested in their own progress. Modification marks a clear shift toward redesigning tasks. Technology enables substantive changes that alter learning outcomes. This stage leverages collaboration, creativity, and new workflows to make activities more authentic, interactive, and aligned with real-world practices. A hallmark of modification is collaborative document work where multiple students edit in real time, provide peer feedback, and co-create living documents. These approaches foster interaction, critical thinking, and dynamic revision processes that mirror professional collaboration and deepen student ownership of learning. Powerful modification examples include student-created podcasts or video documentaries that synthesize topics, global classroom projects that enable cross-cultural dialogue, and virtual exploration tools like simulations that let students investigate phenomena otherwise inaccessible in a traditional classroom. As one expert puts it, engaging students with a wider audience transforms learning, and global collaboration projects do exactly that. By connecting learners across contexts, you build communication, digital citizenship, project management, and authentic problem-solving skills that prepare students for an interconnected world. Redefinition sits at the pinnacle of transformation. Here, technology enables tasks that were previously inconceivable without digital tools. This stage unlocks wholly new learning experiences that expand creativity, audience, and the very nature of what it means to learn and demonstrate understanding. Redefinition goes beyond extending tradition to creating immersive, interactive experiences. Imagine students producing VR reenactments of Shakespeare, or building simulations that let them test scientific models. These activities reconfigure learning so students become creators and explorers, rather than passive recipients. In practical terms, redefinition includes language exchanges that connect learners with native speakers in real time, student-built simulations and educational games, and global portfolios that publish student work to authentic audiences. Each example emphasizes creation, agency, and broad impact. To amplify SAMR's potential, consider the quintet framework. 5 complementary dimensions: social interaction, gaming mechanics, mobility, visualization tools, and storytelling that enrich each stage of SAMR by adding collaboration, motivation, anytime access, clearer representations, and emotional engagement. When using SAMR in the classroom, start where you are and align technology choices with learning goals rather than novelty. Blend different stages strategically depending on students and resources, and reflect regularly on impact, so your integration remains purposeful and student-centered. A case study with a platform like Nearpod illustrates SAMR's progression. It can serve as substitution with digital handouts, augmentation with interactive quizzes, and embedded media, modification through collaborative virtual lessons, and even redefinition via immersive VR field trips that transport students to new environments. Common misconceptions include thinking SAMR is a strict ladder you must climb, assuming higher stages are always better, or prioritizing flashy tech over meaningful outcomes. The model is flexible. Choose the stage that best serves your instructional goal and focus on authentic learning rather than novelty. In conclusion, embracing SAMR empowers teachers to transform learning with intention. Use it as a roadmap to guide thoughtful technology integration. Prioritize learning outcomes over tools. Start small and scale thoughtfully. And remember that the ultimate aim is richer, more meaningful experiences for every student.